operation we will look at is multiplying rational expressions. And so if I'm looking at an example, I like to look at a numeric example first, and I'm looking at something like this. We're all used to doing something like this where we might go, okay, well, I can cancel, cross cancel, or cancel up and down any common factors will cancel out of any numerator with any denominator. Or you can think of, okay, I divide this one by 2, divide this by 2, because 2 goes into each of these, and divide this one by 3 and this one by 3. But let's show it in a factored form just to emphasize this. That's what we're going to actually be doing when we get into the algebra version of this. I mean, when we look at things with variables in it. So, and this right here, 3 is factored, or 3 is a prime number. So 3 times 1 is the only factors. 3 and 1 are the only factors of 3. Now 4 is 2 times 2. I'm just going to break it down. 14 is 2 times 7. And 9 is 3 times 3. So all I'm doing is just factoring each of these just to show you that now any common factors can cancel out. So 3's cancel here, 2's cancel here. I don't think there's anything else, so you can multiply straight across, and you should end up getting, we'll just put this down here, straight across I should get 7 on top, and it looks like 2 times 3. Now you can just multiply that out since they're numbers to simplify, so you'd say 7 all over 6. I left this for a reason because you'll see it's acceptable when you have a factored version at the end, just as long as there isn't any comments to cancel when we deal with the algebra version. But 7/6 is how I would answer that. That's the reduced fraction form, improper fraction form. So that's a numeric example. It's the same as you divided out a 2 out of each of these, and you divided a 3 out of each of these. Same concept is what we're going to do over here. These things look scary, but the process that you want to always go through, they're not as scary as they look. The process is, all right, if anybody ever asks me to multiply these, what I want to do is rewrite it, everything in factored form. So you want to factor everything first, right off the bat. And so this is prime, right? It doesn't factor at all anymore, it already is done. This one we know x and x, what multiplies to be x squared. We do it the quick way because a is 1, and then what multiplies to be -4 adds to be -3. Would be a -4 and a +1. If you multiply these two, you get -4. If you add them, you get -3. Okay, difference 2 squares up here, so x and x, plus and a minus. What's being squared in the back is a 4. This is a little bit harder one. You may have to go off to the side, maybe do crisscross, AC method, maybe trial and error. But make sure that you can factor this thing. And we should get 2x and a 3 here, and x and a 2. And let's see, we want them both negative. So if I multiply this, I get 2x squared minus 4x minus 3x plus 6. But you could do that off to the side, like most of you are using crisscross or whatever method you'd use. So now let's go ahead, and we basically did exactly what we did with this numeric example. We took our original, we factored everything. Now let's just cancel our common factors, which is just dividing it out of each. So I'm going to cancel any common, the whole x minus 2, right? Things have to be multiplied to be able to cancel. And this whole thing is multiplied right here, so I can cancel that out. I have an x minus 4, cool, that's gone. X plus 4, no, I can't cancel that. So that's it, that's all I can cancel. So then I'm going to write my fraction. What's left on the bottom is an x plus 1 times 2x minus 3. On the top is what an x plus 4 looks like, and that's it. And that's an acceptable answer. This is what I was talking about over here. If it's numeric, I would generally just multiply that, and you have 7/6. This is an acceptable answer. The reason being, there's no common factors to cancel anymore. It's sometimes nice to leave it in factored form like that, because then you can just double check to make sure that you didn't have anything canceled. But you'll also see sometimes, go check your answer, say in a textbook or something, that this is not what they gave you for the denominator, because they actually multiply them together like we did with the 2 times 3. So you might see this for an answer, as they will distribute this through and get 2x squared minus 3x plus 2x would be minus x minus 3. So either answer is acceptable. For either of those. And that is multiplying rational expressions. You're going to see a variation of different levels of these, but it's all about the steps are always going to be factor everything, cancel common factors, simplify, multiply straight across.